Hello again. My name is Namakando Mang'elele, and um, I'm still on question one, and I'll be doing the fourth question on question one. That is D. Okay, which says compare and contrast the timbre of the three waveforms. Okay, so I'll start by the sine wave. Okay, so we already know what a sine wave is, and we already know how it sounds. But okay, so let's compare the sine wave to the what's this? The triangle wave. Okay, we'll start with the triangle wave. Okay, so because it says compare and contrast the timbre. Okay, so uh, a sine wave. Okay, a sine wave. A sine wave is a pure um a pure waveform. Yes, it is a pure waveform. Let me just pull out the frequency spectrum analyzer. Yes, here it is a pure. I mean, sorry, pure. It is a pure frequency. Yes, with only one frequency here, which is the fundamental frequency. Yes, it is very. It's a pure wave. It is the purest wave than compared to a triangle or sawtooth wave. Yes, it is very pure. It is very smooth and warm. Okay, as you can see here, it's only excuse only the fundamental frequencies is present here. Okay, no overtones or harmonics. Okay, so it is a pure pure tone. Okay, pure sine wave. Yes, and um, its brightness is very low. It is very low than compared to the triangle wave. Yes, very low the brightness, and it is very clear though. You can hear it. The clarity is excellent. Very clear. Okay. That is the sine wave. Um, Let me just play it. Okay, I'll be playing at the end of the explanation. So, sine wave. And let me just turn up the volume. Okay, so as you have heard, it is a very pure, smooth, and warm frequency. Oh, waveform. Okay, and yes, so that was a sine wave. Um, a very pure, warm, and clear waveform than compared to the triangle and sawtooth wave. So right now I'll be going on the sawtooth wave. Let me just mute this one. Okay, I'll solo that one. Okay, so I'll open up the triangle wave now. Okay, triangle. As you can see down there on the shape, it's triangle, and on the frequency spectrum analyzer, you definitely see that it's different from the sine wave. Yes, just like we said. Okay, so we're looking at the triangle wave right now. Okay, and a triangle wave is the triangle wave is more bright, is a more brighter waveform than the sine wave. As you can see, it has harmonics here and overtones. Yes, It has a lot. Okay, not a lot, but yes, enough overtones, because we still have to look at the sawtooth, and if we said a lot here, we don't know. I don't know what I would say on the sawtooth, because it's more complex. Okay, so the the triangle wave, yes, um, compared to the sine wave, is a bit complex than the sine wave, and a little bit brighter because of the overtones and harmonics. Yes, it is brighter and crisp. Okay, brighter and crisp. And then yes, the brightness is medium, not that bright. It's just medium though. Yes, the brightness is medium. The clarity, yes, it is clear though. It is high. I would say the clarity is also high. Yes, I would say it's kind of clear. Yes, the clarity is high. Okay, so we'll be looking at the sawtooth now. Say sawtooth wave. Okay. Oh, before I go to the sawtooth wave, we have to hear the triangle wave, not so. Okay. Since we heard the sine wave, um, let me turn up the volume for the triangle wave. Okay, so that was a triangle wave. As you heard it, it's a bit brighter than the sine wave, and it does not only consist of one single frequency. Okay, so compared to the sine wave, the triangle wave is more complex, and it has more harmonics and overtones, or overtones. Yes, because overtones and harmonics are just the same thing. So yes, um, okay, and as you can see, and you heard it, it's a bit crisp. Yes, not as pure and warm as the sine wave. Okay, so right now I'm going to jump into the sawtooth wave. Okay, sawtooth wave, sawtooth wave. Okay, sawtooth wave. Okay, so this is a sawtooth wave, as you can see here. It's way more complex than the other two, the triangle and the sine wave. It's a bit similar to the triangle because of the harmonics and overtones, but compared to the sine wave, it is way different and way more complex, because the the sine wave only consists of one frequency, which is the fundamental frequency, which is here. Excuse. But the the triangle the triangle wave and sawtooth wave have harmonics and overtones. Okay, so the triangle wave and sawtooth wave are a bit similar, but not that similar. They're different. Okay, but they're both bright. Yes, and um, they're both bright, and the brightness is high. Yes, they're very very bright waveforms. Okay, so here is the sawtooth wave. It is very 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 complex, as you can see. a lot of overtones. Like I tried to say in the previous waveform, a lot. Now this is a lot. As you can see, you can tell. Now do a comparison on the three at the end, so we can see how they look all together, and you can tell that okay, it is very 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 different. Okay, so as you can see here, this is the sawtooth wave. Uh, Very bright and buzzy. You get to hear it when I play it. It is very very buzzy. The triangle wave is just a bit crisp, but the sawtooth wave is very buzzy. Okay, and aggressive. Buzzy and aggressive. Yes, it's very buzzy and aggressive. Clarity, it's not that clear though. Yes, it's not that clear. It's like, I should say maybe medium. Yes, because it is very very aggressive. Okay, so this is the sawtooth wave. Let me just play it so that we can hear it. Okay. So we can hear it. Okay. Okay, so as you can see here, this here is the sine wave, this here is the triangle wave, and that is the sawtooth wave. Okay, as you can see there, they are very, 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 very different waveforms. As you can see, they're very different waveforms. Okay, and thank you for watching this video. I'll see you on the next one. Okay, goodbye for now.